Okay, 5, 4, 3, 2, 1. Everything that you learn in this next unit is new. Once again, the days of showing up to math and being like, we're going to solve things that you saw in previous years, those days are absolutely over. Now, with that, we try to take it step by step and try to not move too quickly. Notice that the key word here is derivatives. Calculus is about three big ideas. Number one, limits, and we've seen all the things that we need to see about limits, right? We're going to see two more things about limits, and they're really cool. They come with applications of derivatives and things like that. It's pretty cool stuff. But the other thing that we see is what we call integrals. And so integrals are super awesome. They're like the most powerful thing in all of calculus. But limits tie these two things together. About 10% of the course is on limits, and about 40% of the course is derivatives, and about 40% of the course is integrals. You're going to spend the rest of semester 1 talking about derivatives, okay? Semester 1 talking about derivatives. Semester 2, we'll jump over to integrals, and that's where we'll be living. Those are two things, again, that we don't know yet. We're going to show you the full construct, and you guys should hopefully be very good at it. So, what is the definition of a derivative? A derivative is something that is based on another source. That's the definition, something that's based on another source. So we derive something, we take something from something else. So in terms of x and y, it's this. The change in x I'm sorry. The change in y with respect to the change in x. Now, there's a few ways that we can write the change in y with respect to the change in x. For those of you taking physics, this would be a delta y over delta x. The way that you guys see it is you see y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So what is that? Slope. So other words, that implied derivative would be slope. Another thing that would imply a derivative would be rate of change. And we come up with this other definition. If you remember, we had definition 1 for slope of a tangent line. We had slope was equal to the limit as x approaches a of f of x minus f of a over x minus a. So that's what we used to live with, okay? We're going to change that definition to a derivative. The definition for a derivative will be slightly different, and it's going to look like this. This is cool. We're going to draw our graph, and on that graph we'll place a function. Remember, the first goal of calculus, we said, was to find the what? Find the slope of the tangent line. So that is our derivative piece that we're looking for. So I've got this spot there, and we are going to call that point A. Okay? So that is coordinate A. Okay? Who can tell me what this would be then? Don't say L. F of A. Pause. Is everybody okay with my drawing so far?
Yes.
We've seen that a few times, right? Yeah. Okay. Now, the next piece is that we're going to move over a certain distance. So instead of picking a new point called x, I'm actually going to move a certain distance, and that distance I'm going to refer to as h. And that's going to bring me to a new coordinate, which I call a plus h. A plus h. So we create that second point, and that will give us the slope of the secant line. Since you guys know everything about limits now, this isn't going to be any problem for us to work through. What do we call this y value up there? F of a plus h. Okay? Yes. Yep. Thank you. Yep. Yep. Wait for it to happen. So you guys all see it in the moment. Yep. No, she sees it. Okay. So let's. I'm gonna put this all together. You guys keep an eye on what you got, and we should have an aha moment here. So remember, we have slope. So what's your y sub 2 value on the picture? F of a plus h. Okay. And then we're gonna minus what's the y sub 1 value? F of a divided by what's the x sub 2 value? A plus h, and what's the minus a? What happens in the denominator? They cancel out, and you get this beautiful picture that we've actually seen this before. You see f of a plus h minus f of a all over just h. As Allie said, does that look familiar to you? Yes. Yeah, we did it last year in pre-calculus, didn't we? We actually showed you how to work with this thing when we're evaluating functions. You've actually seen this. We prepared you for it. You have those skills in hand. So we're going to use this definition algebraically probably on Friday. I don't know if we'll get to it tomorrow. But the idea is that right now this is the slope of the secant line. So last year I had you do it, and you were like, well, what's the big deal? And if I would have told you the slope of the secant line, you would have been like, what the heck is a secant line? Well, now you know what the slope of the secant line is, right? So now I don't want the slope of the secant line. I want the slope of the tangent line. So what am I going to do with these 2 points? Move them closer together. What happens to h as I move them closer together? H gets smaller, right? In fact, we want h to go towards what value? A plus h moves towards a, but the value of h moves towards 0. And so we slap on limit as h goes to 0. That's the definition of a derivative. And just to be clear, we didn't make that up. That comes from right at this picture. And to show that it's a derivative, we have a new operator in mathematics. That's equal to f prime of a. When you see this little comma thing up there, apostrophe I should say, that means a derivative. So you're familiar with operations, addition, multiplication, subtraction, division. Give me some other operators in mathematics that we use. Roots, powers, e to something, natural log, absolute value. These are all operators, right? This is the most powerful operator you've ever used. To do a derivative, just that one mark, it means you do all of that. That's what it means. Good. All right, let's do the easy stuff. We start basic. This is the function f of x. Arrange the values in increasing order. So it's asking me to arrange f prime of -4, f prime of -3, f prime of -1, f prime of 1, and f prime of 3. What that means is the slope of the curve at that x value. So tell me something about the slope of the curve at -4. Tell me something about the slope right here. Yeah, it's really negative, right? So I'm going to just write like super negative. Okay? Yeah, like, okay, super negative. Against at the senior class meeting on Monday. Sorry if I scared anybody. I wasn't trying to scare anybody.
I think you scared the right people.
Okay, that was the goal. When certain people open their mouths, I get mad. Okay. Okay. So, okay.
I knew it was coming.
I didn't hear it, and then you just got
I could see you were in the corner and you were stopped. You were like about to burst and you had to say something. And then we're like, oh, here he comes.
Okay. What about the derivative at -3? What do you notice about the slope or the derivative at -3? How would you describe that?
It's plateau.
Yeah, it kind of plateaus. What do we call that kind of slope? Zero. Yeah. Then I've got slope at -1. So I could go over to -1 and I want to look at the slope there. How would you describe that slope? Yeah, it's positive. How would you describe the slope at +1? Yeah, it's negative. How would you describe the slope at +3? Yeah, it's super positive. So I don't have exact values here except for the f prime of -3. Looks like it's probably 0. And what we want to do is we want to be able to order these from least to greatest. So it's not in terms of height of the function. It is more in terms of the slope value. So therefore, f prime of -4 is the smallest. What's the next smallest? Don't say 1. Thank you. F prime of 1. What's next? Yeah, f prime of -3, because that would be 0. And now I could go to my positive values. I have f prime of 1, and I have f prime of 3. Okay?
But you have it be negative.
-3 in the middle.
Sorry, yeah,
-1,
-3. Sorry about
and
that.
negative,
Yeah.
-1.
Sorry. Wow.
Next
Wow.
one, that one.
Yeah, okay.
Wow. Bad Mr. Gaines.
Yeah.
I will start giving you guys $1 every time I make a mistake.
Actually,
You guys give me $1 every time you make a mistake.
yeah, I didn't know that.
All right.
I actually just use
You
all
actually,
that.
you bragged about your degree.
I didn't brag. I stated a fact.
Oh, we need to have the little less than.
Okay. So
Yeah,
Oh, I
it
didn't
says
know that.
arrange the values and increase it.
here's what I need you to do right now. I want you to talk to a friend, and I want you to compare these two things. I want you to compare f of 1 and f prime of 1. Which one's bigger? Which one's smaller? Or are they the same? And how do you know? Think about it. We're trying to just extend a little bit. Think about it. Talk to your peers. See if you can figure something out about that statement. Go.
F of 1 is 1/2.
How do you know it's like greater?
Because it's where the x, the
It's about prime.
f prime of 1 is about positive.
I don't understand the difference between F and F prime.
That's why we did it right now. So we're going to talk about this just a second.
Perfect.
I was like, this.
All right, I heard some intelligent things. I'm going to go to Hannah right now. Hannah, let's talk about your conversation. Which one do you think is bigger?
F of
Why F of 1?
Hannah?
Are you Hannah? I'm sorry, I didn't hear that.
I was processing the question.
Yeah.
Which one do you think is bigger?
Hold on. F of 1.
So Hannah says that f of 1
Yep.
is greater than f prime of 1. And here's what she's thinking, is that f of 1 is the height of the function. The height of the function at 1 is approximately, I heard you say a value, approximately 1/2. Everybody agree that at the very least it's positive, right? F of 1 is positive because the function sits above the x-axis. That's different than f prime. F prime is the slope at that spot. Say something about the slope at that spot. That's negative. Okay, so you can see obviously a positive is greater than a negative. So that's the difference between f of and f prime of. Okay, notice those pieces. Everybody got that? Okay, flip it over. Example 2, arrange those in order of least to greatest. Arrange those in order of least to greatest. Go ahead on your own, see if you can think those through. Check with your partner, see if you can arrange them least to greatest. Okay? Do your best. Go.
Yeah.
Okay, so let me know if you got something different, because I think that there's opportunity and possibly debate here a little bit. I have f prime of 7 is the least. We agree? Seems like you have the most negative slope at that spot. I'm going to say that's it. And then f prime of -2, I would say that that's pretty steep. I don't think it's quite as steep. And if I would never give that problem to you on the test, it would be absolutely clear which one would be more negative. Okay. But I want to make it a little bit, I want you to really think a little bit about, trying to compare these a little bit. I think that one's steeper personally. And then f prime of 0, I would say that that's kind of the least negative of those slopes. We agree? And then f prime of -5, that's 0, right? And then f prime of 2, that's kind of slight. That's maybe like, say, a +1 for a slope. And then f prime of -4, I think that's where it's really steep. So I could see maybe mixing up these two a little bit, but I think the rest of them, I think it's pretty clear. You okay with that?
Yes.
Okay. So being able to compare those is an important step. Okay. So when we do derivatives, we're going to be looking at graphs, we're going to be looking at tables, and then eventually we're going to be looking at, on Friday, we're going to be looking at some algebraic work as well. And so what I want you to do right now is open your homework, just so you can get started a little bit. So the first assignment is like a page and a half, so it's 3 pages, a page and a half front and back, so to speak. But the first part on the front, it asks you to simply just order those, and then it does ask that question I asked you guys, which is, which is greater, the f prime of 1 or the f of 1 type situation. So that will help you figure out that thing exactly that Lily is talking about. So I would encourage you to try to look at those 4. You take a little bit of time. Obviously, class is going to be out pretty soon. So. And then tomorrow we'll continue on with that exact same lesson. We'll just need to extend a little bit further. Yep, I would just do those 4 on the front right now. Focus on that.